My name's Zipilli. I'm one of the product managers at Google Cloud Storage. Actually kind of new to product management. Before that, I was a solutions architect, and then before that, professional services. I've been building stuff in clouds for years and specializing in GCS in the last 3 or 4. So I'm going to cover sort of the overview of cloud storage, a little bit about what we're doing in terms of optimization, although that's going to be AutoClass, which I know we just discussed some, and then a little bit about the dual regions and Turbo Replication, wherein I have a demo, which I'm going to attempt to do live. Hopefully, I won't tempt fate too much with a live demo. So why cloud storage? One of the things that I like about cloud storage, and I know our customers like, is that it's very simple to use. There is one API across all the storage classes. We discussed that a little bit in the earlier talk. That's available at a global endpoint, which is really nice for RTO in DR scenarios, for example, because you only need one endpoint to configure your application to use. And of course, the latency is low and consistent across all those storage classes, which is really just simplifies the work you have to do and the thinking you have to do to use those. Also, the replication here is fully managed and configurable. So you check a button, replication's happening. There's no concept of like failover and failback that you have to manage. And I think there was a little bit of discussion about the strong consistency model. I'm going off the script a little bit. One of the things I really like about the way replication works here is that in those dual region and continental configurations, that metadata allocation for storage is consistent across those distances, which is really nice. So you don't have to worry about eventual consistency and like at some point the objects will show up in some other location. It's there when you write it in the metadata, which is really nice. The scalability of GCS is outstanding. There's no limit on the number of buckets you can create, no limit on the number of objects. And of course, the performance scale goes very, very high, as mentioned. And the security is excellent as well. So there's only options to store encrypted. You can do various kinds of key management configurations, but that's the way we store things, both at rest and in transit. And there's good transparency on data access, really strong audit logging, and features like that, so you can see what's going on. So ideal use cases for cloud storage, content delivery is one. So doing like low latency, high QPS content serving to end users works really, really well here. Those are all the use cases for that. Definitely a lot of analytics, machine learning workloads here. I spend a lot of time on those personally. Those work very, very well. In particular, the scalability works out really well. And of course, there's backup and archiving use cases as well. So, we have very low cost archive storage with millisecond latency to retrieval. As mentioned, there's all kinds of geo-redundancy options. And of course, we have partners in the backup and DR space that make all that a lot easier to do. Just another overview of the location types. So there's regional storage. And then the multi-region is the sort of continental setup that was discussed. And then dual region, which is where you're pinning things to specific regions. In general, yeah.
Is cloud storage plugged into Vertex and things of those sorts of nature? I mean, can you provide, machine learning data in an object store format and feed it into a Vertex machine learning cluster or whatever and that sort of thing?
Yeah, it's a very good question. And in fact, yes, and I can give you a little bit of detail about that. One of the things that we found was that, machine learning researchers are not data engineers or infrastructure engineers. So, they have a lot of expertise in their field, but making storage hard for them to get to is a big problem. So one of the things that happens when you run Vertex is you get a fully managed fuse mount of GCS.
Man, what?
So what's nice, a fuse mount. So that way you don't have to write your PyTorch or what have you to use object storage specifically. You can take what was working for you on your local storage and begin to use it in GCS. You don't have to make that port. I'm not going to sit here and say, because I think the audience here is probably familiar with fuse drivers and then their advantages and disadvantages, and say that like, hey, it works exactly like a local disk. Doesn't, but the core sort of access patterns and usability is very, very strong, and it goes a very long way for most Vertex customers. I think at the high end, the fuse thing might start to not work, but it's very, very easy. Never seen it be easier than that. And that is coming, I think you'll see that in GKE as well, the fuse driver from Google. There's open source fuse driver, or excuse me, CSI drivers that let you use the fuse well in GKE, and I think you'll see more of that from us soon. So yeah, and speaking of that, what I was going to say about these locations is I think Dean hinted a little bit at the use case suitability. Multi-region really best for content serving. Regional and dual regional, I would say, are equally useful for general purpose work, including analytics, ML. The main reason to do dual region is the redundancy of it.
Can buckets be GDPR gated kind of thing so that they don't go outside a particular, I don't know, European Union, for instance, or something like that?
Yeah, so I wish I knew more about this subject to answer your question in depth, but what I would say is, I need to go back. So I believe the EU multi-region is EU. So for example, we specifically exclude London these days. So that is one of the drivers for that. That was also a driver for custom dual region. So for a while, dual region was restricted to a handful of pairings that we wanted to support or were able to support. Nowadays, you can select any pairings you want within limits, but it's more arbitrary. So that helps you with those kinds of workloads too, where you maybe EU scope isn't tight enough and you need specific territories. So yeah, that's always been an issue, particularly in Europe. It's funny that this slide, they use the European continent as the example. You could explain this in North America too, but this makes people think of GDPR, and there is a story there for sure.
Right.
And is there a difference in the consistency model between multi-region and dual region?
So no, from your perspective, no. Like the way that it's implemented is a little different, although the core technology is the same. I don't know that I am supposed to say what it is, but put it this way: if you look at GCP's offerings, you'll see a very interesting database called Spanner. And its consistency properties are really familiar to the ones in GCS and the way it pulls those off. So in terms of a mental model, you could look at Spanner 2 and say, oh, okay, that's how the consistency works here, how it works across regions, the atomic clocks and stuff that make Spanner work and pull that off without, leaning too heavily on some part of CAP is kind of the same thing that's going on here. I know we already handled the big question that we always get about storage classes is what? They're the same access time, and I think Dean gave exactly the right answer. Like they're very, very similar. Definitely in the same order of magnitude. Might standard be a little faster? Yeah, like you should probably use standard for high performance applications. But the nice thing is that when you need that data that you've decided to put into archive, it's not a big wait to get it at all. There's no wait. It's in terms of wall time, it's going to be practically identical to standard, which is a really nice bit of one less complication in choosing an archive or lower tier. And the other nice thing I'll point out that's on this deck that may not have come through is that the API is identical. So the storage class you have an object in is really just object metadata field. So you don't have to it's archive, so now I need to go to the archive API. It doesn't work that way. So you can write applications that don't think too much about this problem.
So when you're tiering storage, is it actually like going to different media or tiered media, or is it one of the things we've seen recently is the artificial hold down with API calls, things like that. Effectively, what happens if I want to move something from standard to nearline? Is that going to be instantaneous, or is this going to be a longer term process as that data is moved?
So that's a good question. Without divulging like implementation details that I'm not supposed to, it does move. So when you rewrite, for example, the same object from one storage class to the next, the operation time is on the order of bytes. So
Okay.
it is actually rewritten. As far as like capping API rates, we don't do any of that. Like there's absolutely no change in request rate or anything like that for archive versus standard.
And is moving from one tier to another, is that policy based? Is it command based? Is it both of those, or?
It's both. You have both options. So you can do a lifecycle policy that does that. And so that's kind of like an offline batch process with like, I think the SLO is something like
So going
24
down
hours.
the tiers is as well as going up the tiers as
Not going up. Not going up. Yeah. Right now, policy, unless you do AutoClass. So AutoClass will move things up, but now you're doing more management of these classes. So yeah, lifecycle management today only moves things down and in an offline way. I would say that that's probably the best way to do it in GCS most of the time, but you can always rewrite and like on demand move things into, and of course upload directly into archive or Goldline, whatever you want. So the idea here is that on a time basis, objects get moved into colder tiers, and accessing the object sort of resets that and moves them back into standard. And then as they're not used, they just move back out. So there was a great point in the opening talk about, for sometimes against our financial interest, people will choose stability and predictability over an opportunity to lower costs. I think that's a great point. I think that's actually a lot of the thing that keeps people away from using Coldline and Archive, because they are worried about this sort of like black swan where they have to retrieve a bunch of stuff from Archive and now the cost goes way up. So the idea with AutoClass is to give you really a way to access some of those savings with a little more certainty, since the retrieval fees and early delete fees are gone. So I think that it's interesting that point came up, because I think that's really what this is responding to, that the risk of archive for some people where they don't have a lot of sense of what their access patterns are going to be makes it hard to use. And this makes that, I think, more accessible. Of course, frankly, if you know what your access patterns are going to be, like, hey, these are documents that I'm legally required to keep, and I'm going to read maybe 1% of them ever, don't use AutoClass. Just put them in archive, right? This is for people who, and there are many of them, just don't have a workload with that kind of predictability. So that's why I really think this is a great thing to offer. Before I was a PM, I tried to help customers solve this using sort of cloud user space tools. It's very hard to do. So I think having this is really great.
So if we have a file that transitions all the way down to archive or to any of the lower tiers through AutoClass, and then random user goes through and accesses it, does it now automatically bump itself back up to standard, or are they accessing it at the archive layer? Is it effectively a reset time frame?
Yeah, so this is sort of dovetailing with your earlier question about, like, are we using different storage? I believe the way that this works is that at that point, it would be served out of archive storage, and then I think gets rewritten to standard offline, but I'm not 100% sure of that. Once it moves into standard, like that would be, so like logically speaking, in terms of how you'd be billed, right? That's not a concern. But in terms of the implementation about exactly when it changes the media, I'm not totally sure.
Well, but I mean, you're getting into a tiering situation. So say I've got a backup file that I've got, I'm doing long-term backups. I have to restore, an entire container, and it's 180 days old or something like that. I'm now in a situation where production is down and I'm having to go to the lower tier. It's going to restore at that slower speed? No?
No, so
No, there's no performance difference between these classes.
Okay.
So does it reset the timer though?
Yes,
So,
right.
so-
You would be back at standard and reset the timer. Yeah, that would
So
be
if
like
somebody
hot
did
data
just-
at that point.
right, so if it was just some random person accessing the data, that means that there would be a charge to delete the data because it had gone back to standard?
No, there's no early delete fees. No retrieval, no early delete. It's the second bullet from the bottom. So there would be no
Okay.
delete fees.
I got you.
That data just becomes hot. It's in use now.
Right.
But yeah, no early deletion, no retrieval. So in that situation, yeah, it would be the same as if it was stored in standard from that point for 30 days, basically, in terms of the cost.
If there's no performance difference between tiers, why wouldn't I just keep everything on the archive tier? And there's
Because
no
of the-
deletion, early deletion cost, there's no retrieval fees, there's no class transition charges, right?
Well, hold on. No, that's only true of AutoClass. So like if you were using archive outside of AutoClass, you would have retriieval fees. You'd have
I'm gonna use,
fees, you would have
okay,
higher
so
costs.
AutoClass is then charged on terabytes regardless of which tier it's on. Is that how it works, or
Right.
is it,
right.
is
And
it
then I believe
charged
there's an-
on, I've got, like 10 terabytes of archive, 5 of cold line.
No,
1
I'm sorry. It's charged based on where the object is according to this schedule. So if you wanted to keep everything in archive, that would mean don't read it.
Don't.
That's
read
the
it.
only way that's going to happen in AutoClass.
So basically what you're saying, if I can try to summate and try to clarify, is you have multiple different types of storage areas. You have nearline, cold line, archive, all these different tiers, but you also have another one, which is AutoClass. It's very similar to
Wait a minute.
another 3-letter competitor that has something called, intelligent. And what it can do is basically, if you put your stuff in that, you don't know how it's actually being utilized, and it will move it based off of criteria. Whereas if I was to do the same thing in Google and I was to choose AutoClass, it can go all the way down to storage. But then if I use that data differently, and it says, okay, well, it would be cost efficient for you to move it to a different layer, it will move it for me. Whereas if I just say, well, I just want to use archive and I just put it in archive, now I'm in a different class under different payment criteria and different usability criteria. Is this basically the confusion that we're running into?
Yeah, it's a good summary.
Yeah.
I'm just going to add one thing, Dom. It's a good summary because by policy, it's promoting and demoting objects across storage classes. The performance characteristics in terms of time to first byte and overall throughput performance is consistent across the 4 classes. The difference is that you have to wait for it to go down to AutoClass, and so you do have that charge. If you want to define from the beginning to go just directly to archive because you know that's your use case, you will have retrieval fees, and so then the operational costs per object access come into play there that you were talking about, Ray. The other thing is that AutoClass here applies to the entire bucket. You don't have to worry about a per object policy definition that you want to apply some criteria to. This is the bucket, and then by policy, based on date, it will demote it. Upon access, it will promote it.
So without,
Yeah, and to add to that was an important delta. The explanation just given before Sean was excellent. The only thing that I was going to say is that there is actually more transparency because you enable this policy, this sort of autopilot on the bucket, which you can disable, and you can see what's being billed as archive, what's being billed as cold line, and so forth. So one difference there is that it's not opaque in that regard.
To raise an original question, I'll say the same question, only differently. Why would I not just stick everything into AutoClass?
Because it costs to do AutoClass, right? So AutoClass is a service and ultimately has an extra pennies
Yeah.
per mile.
So like one example might be you have archive
Yeah.
data on-prem and you're trying to move your archive data into the class or in cloud. Oh, I'm getting all the words mixed up. You wouldn't want to move that directly to AutoClass necessarily because you would have to wait for the time period for it to turn cold in cloud and then get back all the way down to archive. So if you know it's an archive, just put it straight to the archive tier and leave there, and you immediately get the cost benefits of you having your data in archive from day one. Whereas here, it's much more about I'm generating new data. I don't know which of that data is going to be cold over time. I don't know, the let's say the researcher access patterns of the genomes that they're looking at or something to this effect. This way, instead of having to game the system in terms of, well, at 30 days, I move it here and I move it back and, writing your higher level logic, we've done that all for you to make sure you get the best price for storing your data. Is that accurate, Dom?
Yeah, it's 100%. Exactly. Like I think I mentioned earlier, a great use case to go right to archive would be like compliance archives, where I have to keep these documents for 7 years, and I know that I'm really only going to read 1 or 2%. You shouldn't use AutoClass in that case. Dean nailed it. Like this is for people who want to lower their costs, and they know that most of the time a lot of the data is cold, but they don't know which data is cold. And then it really starts to work out. And that's exactly what happened with this Redavis customer. So this was all kinds of so it's a platform for academic research. So they have like some life science, like HIPAA protected kind of data, demographic data. They also have some geographical data. And so they're working with a bunch of universities. And the value that they got out of them is that it keeps the cost low and actually improves the predictability especially when using those colder classes. And they just don't have to think about this optimization. We explored with them, like, could you do this yourself? And the answer was, well, probably, but we think it would actually be less predictable. It would be very difficult to do. So that's a lot of the value. It also de-risks it for them. If you try to do this yourself, there's a lot of risk that you're taking on in terms of getting it wrong. By removing the early delete and the retrieval fees, it's a lot less risky. So yeah, I think this was, this is a private preview customer, but very good success for them so far.
I think part of the challenge we always bump into is because number one, we come from the physical storage world, so we translate this forward. And also we think of the type of data, or if we think of the database, of course, like one modification to a key becomes a hash change to the entirety of the file. So it's like we're mapping all these use cases, and then when you narrow it down, and then the real question is like, why would you do this? Because it seems like it's a customer benefit, and you don't win. And we doubt vendors. We just can't trust that vendors are doing things entirely for our benefit. But it's a challenging problem. But thank you, that mention of moving directly to cold and then only tiering up on access, that was a good sort of catch of where the use case is, where we would move the stuff there and then not have to wait for it to age out.
Right. So yeah, some quick takeaways, but I think we got all these. AutoClass makes it automated, makes it simpler. It does reduce storage costs in a pretty predictable way by removing a lot of the risks, and avoids surprises. So we think that is pretty attractive to customers to look at things this way. So I'll move on a little bit to dual regions and turbo replication. So we talked a little bit about this earlier. The problem we're really trying to solve with these is how do you get consistent performance but still have the redundancy and availability that you need? What are you going to do if there is a regional outage or network partition? Can you continue to operate without a lot of manual intervention? And how can you get that RPO down to something that you need, a much lower number, like 15 minutes. So dual regions, which is GA today, as discussed, lets you choose a pair of regions within a continent. There's a couple of limitations on which regions are available for pairing right now, but we're adding more all the time, and it's a good number of them. All the real popular ones are there. And what's again really good about that, I think I talked about this a little bit. So RPO is one issue. RTO is something that I really like about GCP and GCS myself. By having one endpoint to know, storage.googleapis.com, and the metadata consistency that we have, the RTO is very, very easy, right? So if in a regional outage situation, your application doesn't need to like think about, okay, what's the failover endpoint now? That's not a concern. So I think that, you know, that combined with the metadata consistency really makes things a lot easier to think about. And I do want to mention, you know, in this bullet, it talks about active. So one of the cool things also about that metadata consistency and single endpoint is, and this is in my demo, when you read stuff that isn't replicated yet, but you're in the other region, you just get it. It's served across the regions, but it's not as if it misses, which again makes the replication so much easier to think about. And then of course we're adding the turbo replication. So this is for, you know, situations where you want that lower RPO and you want to know what it is, and you want some take it to the bank assurances that we're getting data actually replicated from region to the other. Now we're offering you that guarantee for a 15-minute recovery point.
And that's different than dual region?
No, that is an option for dual region. So if you don't flag that, there's a slower replication option. I believe, I think it's 12 hours is the RPO on the other one. Maybe much lower in practice, but that's where the guarantee is.
I guess one of the questions from this is always around the application versus the infrastructure and where the data protection is moving. Like, especially in the Kubernetes landscape, we're creating old school enterprise patterns of data protection, replication, redundancy, which is sort of, I say, old school, that's right. Because the Kubernetes sort of fanatics and cube first folks would say it's an anti-pattern, but it's not. It's a pattern of usage. But then thinking of an application, say like a RocksDB key value store, where I need this type of level of replication between nodes because it's simply, you know, app node based. But I generally build that at the app layer, not at the storage layer. So I'm curious, you know, to see what are the specific applications that can use this versus where we would generally find the apps are building these capabilities in the code pattern and the write patterns.
Yeah, I mean, I think if you're writing applications that do that kind of thing where they manage state really well. Well, so there's lift and shift, but I would also point out analytics. They typically don't have that kind of intelligence written into the write path, frankly. You know, we're talking about people doing like Spark, and Spark is being done through an HDFS emulator over object storage. And yeah, you could make that thing write in 2 locations and kind of like deconflict those and all those things. But that sounds like fun to the little engineer inside of me, the younger engineer inside of me, but it actually sounds like a nightmare to me today, right? So I think that's one of the cases. I mean, somebody mentioned lift and shift in the room. I think that's sort of true too. Like there's a lot of backup and DR cases also where, you know, you're going to use a backup DR like provider who partners with us and then going to write into the storage. Yeah, maybe you could configure that to like write to 2 different regions and deal with that. But this is a sort of an easy button for like, here's one backup target with one consistent view of metadata, and it's replicated into 2 regions. So I think there are plenty of use cases. I agree. There are definitely like scrappier app devs who handle state a little more manually and wouldn't necessarily want this. But I think there's a big market of people who see the value in this and would benefit from it. Frankly, as an app dev, it is a little easier to not have to think about that even. You know, even if you do have that option and you want to do that, it's not a bad thing necessarily, especially with the metadata consistency here. So we talked about all of this. So I'm going to skip that. And those I spoke to as well. So like the read after write consistency is there, and reads are served from the region they were written to if they haven't been replicated yet. Key points I wanted to get across. The rest you've heard from me like 3 times at least, so I'll skip that. In this little demo I'm going to do, I haven't built a whole app for the demo. It's all going to be out of the shell. But this is the architecture I'm emulating, right? So we have like compute in one region, compute in the other region. They're using the same endpoint, storage.googleapis.com, and they're sharing a dual region bucket. Firstly, actually, I'm going to skip creating the bucket. Needless to say, there is a UI journey for creating a dual region bucket. You can see the options, but I've told you already that it's different regions and pairings and replication options. So in the interest of time, I'll skip that part and go right to the shell stuff. So I'm running a couple of compute instances here. They're in the same regions that I created the bucket in. So this particular pairing is US Central 1A, which is in Iowa. I don't really follow football, but I thought it would be appropriate to do like a team mascot. So that's the University of Iowa Hawkeyes. And then over here in South Carolina, we've got the Clemson Tigers. Not picking any favorites there. Those are just how I did the host names. But that's where they are, and that's where the pairings are for the dual region. So what I'm going to do here, and let me show you so there's no smoke and mirrors, that the file, what am I looking at here? Okay, the file that I want to show you is not there. I have some data here that I was writing to show you guys the replication metrics, but I might not get to that either in the demo. But otherwise, this is empty. So I'll show you what I'm going to do from here. So I'm going to use a Cloud Storage command called cat. Should be quite familiar to people who have used shell before. What cat does, I'm going to run this on a watch, and we're going to be looking for a hw.text in this bucket here. And it should error right now because that file isn't there yet, as you can see. And then what I'm going to do is from the other region, I'm not going to actually do it through a file. I'm going to do it through a streaming upload through Cloud Storage. I think this is a cool feature. Just nice that it's pretty easy to do, and make that file in that time. So the watch here is running every second. Now shows that data, it sees it immediately, right? One of the things that is less clear to you is that I'm actually using a dual region bucket and that these are actually at separate endpoints. So for the skeptics, you can maybe look at the recording later or something. I did concoct a little dig command so you could see that when I'm using storage.googleapis.com, I'm using different IPs. Note that the first, second, and fourth octets are all going to be similar, but the third never matches. And I spent about 10 minutes yesterday being sure, like, am I right about that? They never match. So those are different servers and different endpoints in those different regions. So just to emphasize the point, and I'm moving very fast here and going way off my talk track, so excuse me if I'm missing anything. You know, whoop, wrong watch. Even when the file is there, mutations to that file propagate very quickly. I think there's a little delay because the command takes a little bit to run. I'm positive that as soon as that was written, it would be able to read those, you know, whatever that is, 20 bytes. And then to clear up any, or to sort of demonstrate that this is active, I want to reverse the roles. And show that like over here.
Then what we're seeing right now is we're basically seeing that it's not a delay in the write, it's a delay in the process of using cat. Like it's this, if
that's exactly right.
Live data, it would be streaming at an incredible rate and then ultimately streaming to both locations.
That's exactly right. So, and again, to show it, you know, bidirectionally, that's happening in both regions, active with, you know, quick replication, basically instant. And again, that really is demonstrating the fact that, as I mentioned, when you read an object that was freshly written from the other region, it's just served across the region. So you don't need to think about like oh, well, I need to go to that bucket to get it because it's new, but 15-minute stuff I can get here. Like none of that is presented to you. That's all here. There is a slide in my deck that we can talk about quickly. So I want to be very clear about what this really means, right? So in a failure scenario, the metadata is fully synchronized. And that's the demonstration we saw where I was able to find hello world text in all its iterations very quickly. But for data that's written and isn't yet replicated, there is possibility of unavailability of that data, right? That's what RPO means. So I do want to be clear that we haven't like gotten to a zero RPO. It works that way, and you can write applications that way. For the most part, you don't have to think about replication in the normal case. But obviously, in a failure case, we still have physics we have to obey. So the data is only in one location, and there's some risk of it not being there in a failure. Of course, when it comes back, unless it was a really bad failure, we're going to end up getting that data back in both locations. But this is kind of what the regional outage, which is a terrible situation, by the way.
So during the 15-minute RPO, if somebody accesses the bucket from the other region or tries to overwrite it, there's going to be some conflict in the data that's ending up here, or is it going to handle it automatically? Because it's going to take 15 minutes before the data actually shows up at the other region, right?
Right.
The data might be there.
So yeah, I think let's talk a little bit about the conflict issue at least. So one of the things that I also really like about GCS as a programmer is the ability to set preconditions on writes. So there's sort of a check and set built into GCS. So you can say, hey, only overwrite this object if it doesn't exist or it only exists at this specific version. So you could write the application to avoid conflicting writes that way if you needed to. It may make sense that, depending on how this application is written, that just look, while this region's down, the other region, its writes take precedence and it can overwrite. But you have that option in how you write the application. That is solved, though, to your point, in the application layer. Like that is one thing you have to think about. But I think that makes sense because for different applications, the right answer is going to differ.
And the 15-minute RPO is only available with Turbo Replication?
That is correct.
On Turbo Replication, the RPO would be undisclosed, or?
I am trying to remember. I believe it's 12 hours. I hope I'm not saying the wrong thing. Undisclosed might be a safer answer at this point, but I know we're going to have a specific number on that.
Are there metrics exposed to the customer that help show the effectiveness
Excellent
of the
question.
replication?
Yes, there are. I wanted to talk about that. So a couple things. We are improving the observability sort of by default. These metrics have always been here, but they were kind of hard to see. So now, like, very easy to get to. This is a sort of a preliminary dashboard. And then for the purposes of this demo, I did put together like a replication dashboard. So yeah, you can see in this, so a couple things. There's like a metric for, are we meeting RPO? There's not a specific metric for like how long did it take to replicate every single object? But we report to you if we went outside the RPO for that bucket. There's also metrics about how many replications have been done. These are right now a little course. I believe it's like a 4-hour chunk. So I wrote a script to write from like devrand into here, and that's what you're seeing. That's what was in that data folder. So those metrics are there, and I think you'll see these get tighter over time and a little more informative. I do want to clarify too about these RPO numbers, because there was a question about like, well, what's it if you don't have turbos and undisclosed? Regardless of what it actually is, keep in mind those are a lot like SLAs, where that's the guarantee and the outer bound. In practice, I think people will find the RPOs are tighter than that most of the time, but that's where we can make a guarantee. So let me be clear.
So a bucket can be extremely large, or an object can be extremely large, you're guaranteeing that you can replicate it within 15 minutes across region?
Well, there is a limit of 5 terabytes per object.
Only 5? What?
Per object, right?
Per object.
Not
Yeah.
Okay.
I think he was joking. Yeah, although we did have somebody with a 14 terabyte object in a transfer appliance recently, and it's a little bit of an issue. But yeah. So there is an outer bound on what a single object replication could be, and so yeah, that's where this comes from. And keep in mind, like I said, we're not doing dual regions across the ocean or anything like that, right? We're not doing transatlantic dual regions right now. I don't know if we will, especially with turbo replication. So that's how we get to those kind of guarantees.
I was just going to add then on the one point is back to Sean's earlier point around our network, and that's something that we leverage in this type of scenario. And then the other point is to the on-prem statement, right, is that we always like to talk about things that are like SLOs and SLAs versus, best efforts, where, cloud, I think, really has that value, right, in providing those bounds versus saying, well, I'll just replicate as fast as I can, and then let's hope for the best.
Well, and just to double check, see the policy of data size, data movement size is a per object, per bucket, because there's combinatorial things, right? Because I could have 7 4.8 terabyte things that happen in one bucket, right? And I'm not going to make that where
we know how much we've provisioned for you in order to upload your data, so therefore we kind of know how much we need to provision to replicate your data, if you see what I'm saying.
So it is simply an object per object limitation on size, not
that
buckets.
And that's actually just a GCS and an S3, like that's a standard object size type thing is 5 terabytes.
Right.
That's been around forever.
But yeah, unlimited number of buckets, unlimited number of objects in buckets. So yeah, the limits it's just that object size limit.